Hi everyone. Here's a short video explanation for this problem, section 4.4. We're talking about how to find inverses of exponential functions. So the first step is to replace our function notation with y. So the g of x becomes y. And just like all the time when we're finding inverses, the next step is to swap the x and y values. So just like we know the domain and range switch for inverses, we're switching the x and y values. So literally every x becomes a y and vice versa. X is 4 to the y minus 1 minus 2. So now what is our job from this point? It's to try to isolate y. So in this next step, our job is to try to get the term with y alone. So my next few steps, our goal is to isolate y. So this term has y in it, which is great, but I need to get this 2 on the other side. So I'm going to add 2 to both sides. Now when we get to this step and we see that y is in the exponent of our base, which is 4, here's where we need a logarithm to get that y out of the exponent so that we can get it isolated completely by itself. So my next step here is to rewrite this exponential equation in logarithmic form. So we think back to how that works. So log base, well, the base of my logarithm is also the base of my exponential function. So log base 4. So I always think it's going to be 4 to the exponent, because logarithm, the word really just means exponent, y minus 1, and then the inside, or the argument we call it, of the log is x plus 2. So if I wanted to check, I always take the base 4 to the other side of y minus 1, and that should equal x plus 2. So if I do a quick check, I would get y, actually, sorry, I meant 4, oops, 4 to the y minus 1 equals x plus 2. And then I just check that that's equivalent to the previous line, which it is. So that's great. Now, remembering that my goal is to completely isolate y, I'm almost there. I've just got a 1 subtracted from the y. So now to get that y completely alone, I'm going to add that 1 to the left and the right side. Y is equal to log base 4 of x plus 2. And then we just have this plus 1 added to it. Now the very last step is to replace y with our function notation for inverses, which if we started with g of x at the very beginning of our problem, the inverse notation is g inverse of x. So that's my very last step. G inverse of x is log base 4 of x plus 2 plus 1. And that is our answer. Now, there are a couple ways we could check this. A great one would be to plot both of these on your calculator, and remember that inverses reflect across the line y equals x. So you could verify that with your calculator. You could also check the table and make sure that the x and y values are just being swapped. So I hope that helped a little bit with this problem.